Okay, so on part one of the 2.7 day one notes, we graphed absolute value functions and really just kind of saw how things in front, negative signs, as well as inside and outside of the absolute value bars, how do they affect our parent function? So here, what we're really going to do is actually summarize everything that we did and really give out some vocabulary words and talk about the general form of the absolute value equation. Afterwards, then we are going to do some problems, basically figuring out the transformations without graphing absolute value functions. So the general form of an absolute value equation is y equals a times the absolute value of x minus h plus k. Now remember, when we did this in part one and we were talking about the transformations or our observations of the graphs, the a value, right, was in front. We had a number inside the absolute value, that's going to be our h, and then the k represents anything that is outside. So how does the value of k affect the graph? Now when we did this, right, I'm going to go back to our observations that we did before. So our k is going to be the value outside. So remember on number 11, we talked about how did that value outside affect our graph. Well, we said that the graph went up, right? So on both of these, they either went up or down, but they went vertically, right? So that's basically what the k value does. So if we have a positive k value, I'm going to go ahead and do this in the same color there. I like color coordinating. Do green. There we go. If we have a positive k, as we saw in our observations, right? When we had a positive k, like this positive 2, the graph went up. So anytime we have a positive 2, that means that our graph is going to translate up. And now our key word here is going to be translate. That's going to be our vocabulary word that we're going to use from now on, okay? Now if we have a negative k, as we did see beforehand in our observation, we said when we had a minus 3 that our graph went down 3. So that's going to be in this case. So that means when we have a negative k, we're going to translate, and that's our key vocabulary word, translate down. Another way of what we like to call this is what we also say, this is our vertical shifts. So like we vertically go up or vertically go down, okay? Okay, now let's look at how does the value of h affect our graph. H was inside our absolute value bars. So we go to those questions from part one. We're going to look at number 12. This is where we had values inside our absolute value. So it looks like it moved our graph to the left and right. So it moved it horizontally, right? Okay, so it looks like if we have a plus and whatever the h value, it moves the graph to the left. So that's what we're going to talk about first. So that was blue. I'm going to use that. So if anytime we have x plus h, then what happens is that we translate left, or we horizontally shift. That's another way of saying it. But we're going to use the word translate. So that's our keyword, translate. That's our vocabulary, and left. Now when we had x minus h, as we saw with, I think it was x minus 4, we talked about how the graph moved to the right. So that means when it's x minus h, we're going to translate right. Now, some of you might be asking, well, why is this? Like usually when we see a minus, that means it's, negative. And if we think negative, right, it goes to the left. Well, let's talk about what's really happening here. So let's just say I have my x minus h, and let's say I plug 4, okay? 4, the number 4, right, is a positive number itself. So if I plug a 4 into this x minus h, right, I just do x minus 4, but if I plug a positive 4, that's why it's there. Now let's think about it if I plug a negative 4 into h, right? -4, so I plugged 4, which is a positive. Let's say I plug a -4, which that's negative, so that means that should be to the left, right? Or correct, should I say, is that correct? So let's say I plug that in, but I'm going to plug it into this. So I have that minus sign still, so I have a minus and then a -4, and -4, that is to the left. So now remember, when we have two negatives, well, what does it make it? That makes it into a positive. So that's why when we look at our H, it's going to be the opposite of what we see. Because when we plug a positive already into the H, that's why we have that minus. But if we plug a negative into H, it makes it a positive. So that's why we have the opposite sign for when we go left and right. Okay. So let's go ahead. I'm going to erase this here. And then I do want to indicate, just so we know, this is a vertical shift, because you might hear me say that quite a bit. And then for our H, that is going to be a horizontal shift. Okay, so now let's look and talk about how does the sign and the absolute value of A affect the graph. So this is where we talked about in really numbers 13 and 14 of our questions. Now let me talk about first number 13, where we had a number in front, okay? So when we talked about it, we said when a number is bigger than 1, we got wider, and when the number is bigger than 1, we got narrower, and when the number was smaller than 1, right, it made the graph wider. So let's talk about specifically what that means. So let me go back, and I made that red. Okay, so if we have the absolute value of A and it's greater than 1, we call that a vertical stretch, and that's going to be our key word. And we're going to talk about what this really means here. So the graph becomes narrower. But if our absolute value is in between 0 and 1, so the absolute value of A, and basically we want to take the absolute value of that A value, it's because the negative only affects it when it opens up or down. The A value really tells us what's happening to it if it's becoming narrower or wider. This is what we call a vertical shrink. So that means our graph is getting wider. And then the vertical stretch and shrink, those are our key vocabulary words, okay? Now let's talk about what does this really mean, a vertical stretch. Well, if we think vertically, right, that means up and down, okay? So if we go back to those problems that we graphed, what is really happening when we have like a vertical stretch, which this is in this case because 4 is greater than 1, okay? What is happening in that is 4 is what we call our slope. And we'll talk more about that when we actually graph these absolute value functions. Meaning that our slope or our rate is actually increasing at a faster rate. So because it's increasing at a faster rate, we stretch this and it's becoming going faster up. So it's vertically stretched upwards, okay? So that's why we call it a vertical stretch, because the rate or the slope is going at a faster pace. Now, with a vertical shrink, though, right, we're shrinking vertically. Our slope, like in number 7, since it's 1/3, our slope is going at a slower rate. It's not going as fast. So that's why it makes it wider, because the slope is not as fast. But that's why we call it a vertical shrink as well, because we are not going quickly on our pace or our rate. It is slowly getting up vertically, okay? So now our last thing we do need to talk about is the sign, so the positive and negative. So when you have a positive a value, like for most of our problems, basically we're going to open up. The graph is going to open up. But if we have a negative a value, our graph is going to open down. And when it opens down, this is what we call a reflection. It flipped, right? So we talked about this in our last question. The negative sign flips the graph. So another word that we like to use, and this is our key vocabulary word, we call this a reflection. So that is our key vocabulary word we will use. Okay, so here we have it, indicating how each of these values, A, H, and K, affect our absolute value equation. So we have our K, which vertically shifts. We have our H, which horizontally shifts. We have our A value, which does two things. It can flip our graph, so that's where we have a reflection. Or if we have the absolute value is greater than 1, it's a vertical stretch. But if it's between 0 and 1, it's a vertical shrink. Now, one thing I do need to indicate is anytime that our A value is equal to 1 or -1, there is no vertical stretch or shrink, okay? Because it's not really changing. It's not becoming narrower or wider. Okay, so make sure you have this down because we are going to use this information to go ahead and describe the transformations of certain absolute value functions without actually graphing them. Okay, so let's kind of do these ones here. So we're going to describe without using a calculator or other graphing device how the graph of the given equation is related to the graph of the parent function. What that means here is we are going to describe the transformations. That is what it's really just talking about. Okay. Now, sometimes we might have just one or two, or we could have all four type of transformations. There we go. Okay, so describe transformations. So here we have f of x equals the absolute value of x plus k. Now what I would advise is writing the general, because once we know the general equation, that kind of helps a little bit. So remember the general equation, we have y equals a times the absolute value of x plus k, sorry, x minus h. Get my head of myself here, x minus h, and then plus k. Now what I like to do is kind of just go from left to right to see if we have anything. Okay, the first thing is our A. Well, if I look, I don't see a number. When I don't see a number in front of my absolute value, I can assume that is 1, okay? And because our A value is 1, well, there is really no vertical stretch or shrinks. As well as since we have a positive 1, there is no reflections. Now, if I look, there's really no H value, okay? So that means I don't have any vertical, a horizontal shift. And then with the plus 6, that's where we get into it. That is our vertical shift here. So that is going to mean, since we have a plus 6, going back to our list, our summarization, when we have a plus k, that means I translate, and once again, that's our key word here, I translate up 6. So I do have a vertical shift for this one. Okay, let's look at our next one. So I have the absolute value of x minus 4. Okay, once again, my a value is 1 because we can assume that since that's the number. Because it's positive, we do not have a reflection. Because it is 1, there is no vertical stretch or shrink. If I look, there is no h value, otherwise I would have a number inside that absolute value. So there is no horizontal shift, but I do have this minus 4 that deals with the k value. And so whenever we have a minus k, remember that means we translate down. So in this one, I would say translate down. Now, what I would advise is making sure that you have your summarization sheet with you because it makes it a lot easier to figure out what are our transformations. Okay, let's go ahead and do the next one here. So we have f of x equals the absolute value of x minus 3. Okay. Okay, so now on this one, okay, we have a number inside our absolute value bars, right? So with this one, notice once again, we got the number 1 in front, so there is no reflection, and there's no vertical stretch or shrink, but now we have this h. Now remember, when we have minus h, going back to our summarization, x minus h means we translate right. We have a horizontal shift, and we're translating right. So on this one, we just say translate right 3. Okay, let's try a next one. So actually what I would like you to do is actually go ahead and try the f of x equals absolute value of x plus 2 on your own. So it's going to be similar to our last problem. So go ahead and pause the video and try to describe the transformation. Okay, hopefully you did that. So let's kind of go over this. So once again, our a value in front is just 1. We can assume that because there's nothing else. Okay, so there's no reflection and we don't have vertical stretch or shrink. But because we have a plus 2 going back, right, when we talked about when we have x plus h, we translate left. So we say translate left. And we say by 2. And notice we don't have a k like we did on the last one, so that doesn't mean, so that means we don't have any vertical shifts. Okay, let's go ahead and try the next one. So here, going off of our y equals, and I'm going to go ahead and rewrite that again. So we have the y equals a times the absolute value of x minus h. So it's good to see this because we can go through and see what are all the transformations we have. Okay, now notice that we do have an a value in front. So we do need to take the absolute value of it. So the absolute value of 2/3 is 2/3. Now, since 2/3 is less than or between 0 and 1, that means if we go back to our summarization, since it's in between, this is going to be a vertical shrink. So we have a vertical shrink. I'm going to go ahead and do this as well so we know. So the absolute value of our a is 2/3. So we have a vertical shrink. And then we do want to indicate what is our a value. So we say it's a vertical shrink of 2 or by 2/3. Okay, so we vertically shrinked our graph by 2/3. Now our next thing is, do we see a negative in front? No, so there is no reflection. And if I look, there is no h, so there's no number inside the absolute value, so we don't have an h, so no horizontal right shift, and then there is no k, so we also don't have a vertical shift. Okay, I would like you to go ahead and pause this video again and go ahead and try this last one that is at the end. So determine all the transformations of f of x equals -6 times the absolute value of x. Okay, hopefully you paused the video. If you were stuck, let's see if we can get you unstuck. So we do have an a value. Notice that there is a negative sign in front. So because we have a negative, that means we do have a reflection. Now let's go ahead and take the absolute value of our a. So when we take the absolute value of -6, we get +6, which is greater than 1. Here, this was less than 1. So because it's greater than 1, that means that for our next, we have a vertical stretch. Okay? And so here we have a vertical stretch by 6. So you do want to indicate what is that. Now we don't put it by the -6 because the negative just tells us if there's a reflection. It is going to be the 6 that tells us how we vertically stretch here. Okay, so we have 3 more problems. And now here we are going to get into it where we might have more than just one transformation. So what I would like you to do is go ahead and pause this video and go ahead and try out all 3 of these to determine all the transformations. Okay, so hopefully you pause the video and you try these out. I'm going to rewrite once again our general absolute value equation. So remember, it's a times the absolute value of x minus h plus k. Okay, let's look at the first one. So we have f of x equals absolute value of x minus 1 plus 2. Now notice there is no number in front, so I can automatically assume it's a 1. So in this case, we don't have a negative, so we do not have a reflection. This graph opens up. Our a value is 1, so we don't have a vertical stretch or shrink. But I do see that we have this h value here. So because we have -1, that means we're going to translate to the right one. So remember, really your h is the opposite of what you see. And now I also see a k value. Because I have a positive k, that means I also translate up 2. Okay. So now let's go ahead and do the next one. Notice that I do have an a value here. So let's take the absolute value of a. So the absolute value of 3 is just 3, which it is greater than 1. So that means we do have a vertical stretch. Now, there's no negative, so we don't have a reflection, but I also have an h value here. So it looks like because I have a plus h, remember we do the opposite of what we see, so that means I translate left. I translate left 2. And since there's no k value, I don't do any vertical shifts. Okay, let's go and do our last one. Notice that I do have a negative, so that means I do have a reflection. And notice I have an a value. Now, let's take the absolute value of that a. So I take the absolute value of negative 1/2, which gives me 1/2, which is smaller than 1. So that means I have a vertical shrink by 1/2. I have a reflection because I do have a negative in front of my a value. I have an h value, and notice it's +1, so that means I translate left 1. And I have a k value, and notice it's a +7. So I also translate up 7. Okay. So that's how you use the general absolute value function to indicate and talk about all the transformations of these functions. So if you have any questions, make sure you contact me and make sure you get the homework finished.